Imagine London, not bustling and warm, but silent and frozen. Red buses entombed in ice, the Thames a solid white expanse, Big Ben's clock face lost behind icicles, a city transformed by a sudden brutal freeze. This isn't distant science fiction. Scientists warn it could happen if our climate system is pushed too far. The heat we generate could disrupt ocean currents that keep our climate stable. If those currents falter, a swift generational winter could descend, turning vibrant cities into icy wastelands. Our actions today could set this chilling future in motion. To glimpse this icy future, look back to Montreal, January 1998. Days of relentless freezing rain coated the city in thick, heavy ice. Power lines snapped under the weight, plunging millions into darkness and cold. Steel pylons twisted and collapsed, echoing through the frozen streets. Montreal, a modern metropolis, was brought to its knees, not by war, but by the physics of frozen water. The world glittered, every tree and building encased in sparkling ice. But the beauty was deadly. Ancient trees split and fell, roads were blocked, homes smashed. The city was under siege by nature itself. The storm exposed our vulnerability, our dependence on electricity, on infrastructure, on systems we take for granted. When those systems fail, modern life grinds to a halt. The Montreal ice storm wasn't a global ice age, but it was a warning. It showed how quickly chaos can descend when nature overwhelms our defenses. Our advanced societies are more fragile than we think. The storm was a microcosm of what a true big freeze could bring. It's a lesson we can't afford to ignore. For Montrealers, the ice storm was a fight for survival. Imagine your home growing colder by the hour. Lights out, heat gone, silence settling in. Families huddled in winter coats, breath visible in the air. The comfort of home replaced by a struggle against the cold. With power out, water stopped flowing, toilets wouldn't flush, taps ran dry. People melted snow for drinking water, cooked on gas stoves or fireplaces. Communication failed, phones were useless, isolation set in. Supermarkets emptied, roads were impassable. Emergency services couldn't reach everyone. Neighbors became lifelines, sharing resources and checking on the vulnerable. Makeshift shelters in schools and community centers became refuges. For weeks, survival meant battling the cold and relying on each other. The storm revealed the fragility of our modern existence. Break one thread, like the electrical grid, and the whole system unravels. The experience left survivors with a deep understanding of how quickly order can collapse. It's a stark reminder our comfort is built on a delicate web. When nature strikes, that web can snap in an instant. The Montreal storm was a warning shot, a glimpse of what a true climate catastrophe could look like. We must learn from it. Our resilience depends on it. Earth's climate has a rhythm. Ice ages and warm periods cycling over millennia. We live in a rare, stable interglacial, but history shows the ice always returns. These cycles are driven by subtle shifts in Earth's orbit and tilt, Milankovitch cycles. When less summer sunlight reaches the north, snow accumulates, glaciers grow, and ice sheets spread. At their peak, these sheets covered continents, reshaping the world. Sea levels dropped, land bridges formed, and great beasts roamed icy plains. Understanding these cycles is crucial. They set the baseline for today's changes. Our climate is dynamic, not fixed. The warmth we enjoy is temporary. The past warns us. Dramatic shifts can and do happen. We must measure our impact against these ancient rhythms. The next big change could come faster than we think. How do we know Earth's ancient climate? The answer lies in ice cores from Antarctica and Greenland. Each layer of ice is a time capsule, holding air bubbles, samples of ancient atmospheres. By analyzing these bubbles, scientists link greenhouse gas levels to global temperatures. Ice cores also contain dust, ash, and pollen, revealing past winds, eruptions, and temperatures. The record is clear. When CO2 is high, Earth is warm. When low, it's cold. But the most startling discovery? Climate can shift abruptly, sometimes in just decades. The system has tipping points, and pushing it too far can trigger rapid, unpredictable change. The ice warns us. Stability is an illusion. The oceans drive our climate, moving heat around the globe through vast currents. In the North Atlantic, warm, salty water flows north, releases heat, then sinks, fueling the Atlantic meridional overturning circulation, or AMOC. This keeps Europe and North America warmer than they'd otherwise be. But Greenland's melting ice is flooding the North Atlantic with fresh water, disrupting this process. Fresh water is less dense, preventing the crucial sinking that powers the conveyor belt. If the AMOC weakens or stops, the consequences would be swift and severe. Warmth would vanish, winters would lengthen, and a regional ice age could grip Europe and North America, even as the rest of the world warms. This is the paradox: global warming triggering a deep freeze. The AMOC is a climate tipping point. If it fails, the world changes overnight. Our future depends on keeping this current alive. The stakes couldn't be higher. Volcanoes show how quickly climate can change. A massive eruption blasts ash and sulfur into the stratosphere, reflecting sunlight and cooling the planet. In 1815, Tambora's eruption caused the year without a summer. Crops failed, famine spread. More recently, Mount Pinatubo's 1991 eruption cooled the globe by 0.5 degrees. These events prove the climate's sensitivity to sudden shocks. Some propose geoengineering, mimicking volcanoes to cool the planet, but the risks are unknown. Volcanic eruptions remind us dramatic cooling can strike without warning. Nature's power is both unpredictable and immense. A sudden freeze would expose the fragility of our civilization. Our cities, built for stability, depend on electricity, food supply chains, and transportation. A rapid climate shift would overwhelm power grids, cripple agriculture, and sever supply lines. Homes would become uninhabitable, the vulnerable at greatest risk. Governments would struggle to provide shelter and food. Urban centers could descend into chaos as resources dwindle. Our success has made us forget our dependence on a stable climate. The big freeze is a cautionary tale. Our world is more delicate than we admit. We must recognize our vulnerability. Only by understanding it can we prepare for what's to come. The lesson is clear. Resilience starts with humility. Earth's climate story is one of power and fragility, slow cycles, sudden shifts. The big freeze is a sobering possibility, showing that our actions can trigger unpredictable consequences. For the first time, humanity is a geological force, altering the atmosphere and climate. The carbon we emit today will shape the world for centuries. We must act with wisdom, respecting the planet's intricate connections. Transitioning from fossil fuels is essential for stability. The future of our civilization depends on the choices we make now. Earth will endure, but will we? By learning from the past and acting with foresight, we can preserve the balance that sustains us. Our legacy depends on it.